wondered, Mr. Quering, what does it feel like to be a science teacher? I've got the bro tank just for that. It is Einstein as an astronaut just hanging out in space. You guys selected bro tanks from my college days as the final wardrobe theme of the school year. So I have delivered. In this video, I'm going to do three things. I'm going to explain covalent molecules, how to put atoms together and have them form covalent bonds and make whole molecules out of them. Then I'm going to explain to you the instructions for your final assignment for the school year. It's a project. It's on Flipgrid. Don't be overwhelmed by this. You have 2 weeks to do it instead of just 1 week. And then after that, at the very end, I'm going to give you an example Flipgrid that you can watch so you know exactly what I want from you. So this week we've been talking about covalent bonds, and just to remind you, covalent bonds are where two atoms come together to form a compound or a molecule or something like that, but they don't do it by stealing each other's electrons. They do it by sharing electrons. Now, there's only a certain combination of atoms that is capable of making these types of bonds, and these are non-metals. All right, so as long as they are two non-metals coming together, they can form covalent bonds. Otherwise, it's not possible. Now, just to rehash an example from last video, we have hydrogen here. Hydrogen has 1 valence electron. Fluorine here has 7 because it's in group 17. Now, you'll notice that fluorine would really like 1 more valence electron. That way, it'll get to 8. Hydrogen would also like 1 more because hydrogen is one of those unique atoms that only needs 2 valence electrons to be full. So we have a situation here, right? The situation is that they both want an extra electron. What could they possibly do? And here's what they could do, right? When they form a covalent bond, they could decide to share their electrons. So fluorine is now going to have 8 electrons. So what hydrogen has done here is hydrogen has contributed 1 valence electron, and then fluorine has contributed 1 valence electron, and now they are sharing. So hydrogen has 2 valence electrons. Fluorine now has 8, right? Because if we count the valence electrons within fluorine, it has 8. Hydrogen has 2. Both of them are happy, and they've done it by sharing these electrons. Now, when they share this electron, or these electrons right here, that is what's known as a covalent bond. So the fact that they are sharing these 2 electrons forms a bond between them, known as a covalent bond. Now, just to remind you from last video, fluorine is the most electronegative atom. And what that means, since fluorine is electronegative, is that it holds its valence electrons very close to it. So you'll see here that hydrogen and fluorine, they're definitely sharing their valence electrons, but fluorine is holding the electron closer to itself because it is more electronegative. Well, what we're going to do today is I'm going to teach you how to draw out covalent compounds. So for example, I will give you 2 elements, and I'll ask you, okay, if they were to form covalent bonds, how many of them would need to combine in order for them to all be satisfied? All right, so let's take hydrogen and oxygen as an example. The first thing you'll want to do is find the number of valence electrons, or draw the Lewis structure, right? That's pretty much the same thing. Okay, so hydrogen we know has 1 valence electron. Oxygen, when you look, has 6. Okay, the next thing you're going to want to do is determine the number of bonds that each one wants to make. Well, remember, hydrogen only wants to make 1 bond because it only needs 1 more valence electron. But when you look at oxygen over here, oxygen has 2 open spaces, so it would like to make 2 bonds. All right, so now we figured that out. the question is now, how can we combine these two in such a way that they actually both get what they want, right? So hydrogen gets 1 bond, oxygen gets 2 bonds. Well, what we're going to do is we're going to do something that's kind of similar to what we did with the ionic compounds. What we're going to do is we are going to write this here, and then what we're going to do is we're going to write the number of bonds in the upper right hand corner. Kind of like what we did with the charges, but we're not doing the charges now, we're doing the number of bonds. So hydrogen wants to make 1, oxygen wants to make 2. Now at this point, we're going to do something similar. We're going to cross and drop. All right, so we're going to bring the 2 down here, and we're going to bring the 1 over here. So when hydrogen and oxygen combine together, that shows us that they are going to make a compound or a molecule called H2O. All right, H2O. And you know what? We don't even need the 1 right by it. This is just water, right? H2O. Because if oxygen wants to make 2 bonds, it's going to need to bond with 2 separate hydrogen atoms in order to do that. Now, what would that look like? Let's look at that here. So what would that look like? Well, we would have oxygen here, hydrogen, hydrogen. And what's going to happen here is that oxygen will have 4 electrons of its own, but it's also going to be sharing electrons with each hydrogen. This might take a second for me to draw, but when we do this, we'll notice something here. Okay, so what's happening here is that oxygen has now formed 2 separate bonds. It's formed 1 oxygen, or it's formed 1 bond with 1 hydrogen and another bond with another hydrogen. And so in this situation, hydrogen has the 2 electrons that it wants. This hydrogen has the 2 electrons that it wants, but then the oxygen has 1, 2, 3, 4, 5, 6, 7, 8 electrons like it wants. So at this point, all 3 of the atoms involved are satisfied, and we've actually just made a molecule called H2O. Otherwise, it's known as water. And we can kind of abbreviate that by drawing it like this, where the lines represent these covalent bonds. Let's try another example. What if you had carbon and fluorine? How would you fit those together? Well, let's start by drawing the Lewis structure for carbon. So carbon has 1, 2, 3, 4 valence electrons. So that means that it would like to make 1, 2, 3, 4 bonds. Okay? What about oxygen? Or sorry, not oxygen, fluorine. We looked at fluorine earlier, right? Fluorine has 1, 2, 3, 4, 5, 6, 7. And by the way, I'm assuming that you guys have figured out by now how to draw a Lewis structure and figure out how many valence electrons it has. All right, so fluorine has 1 empty spot, so it wants to make 1 bond. Okay? So now, what kind of molecule will they make? What will be the formula for the molecule that they make? Well, let's try this. Let's go C, F, and carbon wants to make 4 bonds. Fluorine wants to make 1. So at this point, we are going to cross and drop. Let's do that. So we get C1F4. C1F4. And so at this point, we can go ahead and erase these cross and drop arrows. And I can even erase the 1 here. So carbon and fluorine, when they combine, in order to satisfy everyone's needs for 8 valence electrons, they're going to form a CF4 molecule. It's going to be 1 carbon attached to 4 separate fluorines. Well, what is that going to look like? What will that look like if we draw it out? And forgive me here, I'm going to have to erase this just for the sake of room. But what's that going to look like? Well, we're going to have carbon in the middle with 4 fluorines on the outside. And each fluorine will have 6 valence electrons of its own. And when I say of its own, I mean it's not sharing them with carbon, right? But then there's also going to be, each fluorine is going to be sharing 2 electrons with the carbons. Okay, so this fluorine has 8 valence electrons. So does this fluorine. So does this fluorine. So does this fluorine. And carbon, if we look at carbon, has all 8 valence electrons. So this is what the CF4 molecule looks like. And we can kind of abbreviate it by just using, sorry about that. We can kind of abbreviate it by just using lines for the bonds, right? Because each of these shared pair of electrons here represents 1 covalent bond. So carbon is forming 4 bonds, and each fluorine is only forming 1. Now, a little bit of a twist here. There are such things as double or triple bonds. So here, back with carbon, right, we saw that carbon was forming 1 bond with this fluorine right here. And it was also forming 1 bond with this fluorine right here. But that's not always the case. Some atoms can form more than 1 covalent bond with the same atom. So what they're doing here is they're sharing multiple pairs of electrons at the same time. So let's take, for example, nitrogen. If nitrogen were to form a bond with another nitrogen, what would that look like? Well, let's look at nitrogen here. Nitrogen has 1, 2, 3, 4, 5 valence electrons. You know how to find that. And that means it has 3 open spaces. That means it wants to form 3 bonds. All right. So how can nitrogen bond with another nitrogen yet fill all 3 of its gaps for bonds? Well, let's try this. Let's draw a nitrogen and a nitrogen. Well, what if this happened? Right? What if instead of sharing 1 pair of electrons, what if each nitrogen shared 3 pairs? So what if we had a pair here that they're sharing, a pair here that they're sharing, and a pair here that they're sharing? And so that means that each nitrogen then had 1 pair to itself. So here, this nitrogen has 8 valence electrons. So does this one. This nitrogen has 1, 2, 3, 4, 5, 6, 7, 8. And so does this nitrogen. But notice here, they're not just sharing 1 pair of valence electron, they're sharing 3 pairs. And this is what's called a triple bond. This is a triple bond. And so when nitrogen forms a triple bond, we can kind of abbreviate it like this. Right? And this would be a molecule called N2. Right? It's just 2 nitrogens together. All right? Let's try, and by the way, carbon, oxygen, nitrogen, and phosphorus. Those are the main atoms on the periodic table that are capable of forming double or triple bonds. The rest of the atoms on the periodic table, they can only form single bonds. But here, these 4 are capable of forming double or triple bonds. Let's try another one. What about carbon and oxygen? So carbon, we've gone through this before. It has 4 valence electrons, and so it wants to make 4 bonds. Okay. Oxygen, we've gone through oxygen. It has 1, 2, 3, 4, 5, 6, and it wants to make 2 bonds. Okay, so let's go ahead and do the steps that we did before. So CO, carbon wants to make 4, oxygen wants to make 2. Now what we'll do is we'll cross and drop. And at the bottom, we get 4 down here and 2 here. So let's do some erasing. There we go. So when carbon and oxygen combine, they're going to make C2O4. But there's a problem here, okay? And the problem is that we can simplify this, right? We can take 4 divided by 2. We can simplify this further. So when we simplify this, we can take 4 divided by 2 and get 2, and then 2 divided by 2 and get 1. So really, when these come together, they're going to form a molecule called carbon dioxide, CO2. Well, what's that going to look like? What will that look like? Well, let me draw it out for you. We're going to have 1 carbon and 2 oxygens. But here's the thing. This oxygen wants to form 2 bonds. And this oxygen over here wants to form 2 bonds. Carbon wants to form 4. So how can we figure this out? Well, what if we had carbon share 4 electrons with this oxygen and 4 electrons with this oxygen? So then this oxygen would have 2 electrons to itself. This oxygen would have 2 electrons to itself. And then here, what's happened is that carbon has formed a double bond with each of these oxygens. So notice here, this oxygen has formed 2 bonds because it has shared 2 pairs of electrons with carbon. This oxygen has formed 2 bonds because it's a double bond to this carbon. And this carbon has a double bond with this oxygen, a double bond with this oxygen, so it has 4 bonds total. So if we were to simplify this, right, and actually let me erase first. Okay, if we were to simplify this drawing without all the dots, and we just used lines instead, we would have C double bonded to this oxygen, this carbon double bonded to this oxygen, and then both oxygens would have 2 pair of electrons to themselves. So this is what carbon dioxide looks like. And notice, everybody's requirements are fulfilled. Oxygen is making 2 bonds, carbon is making 4 bonds. And so here, at this point, I'm going to give you some instructions for your project this week. All right, so here is your project for this week. What you're going to be doing is I'm going to assign you 2 different atoms, and you're going to tell me different things about them, like what sort of bonds are they going to make, how are they going to make those bonds, things like that. So there's 2 parts to this. Both parts need to be on Flipgrid, so you're going to record this using Flipgrid. For the first part, I'm going to give you chlorine and magnesium. I want you to draw the Lewis structure for it, determine what the charges of those atoms will be, and then I want you to cross and drop the charges and write out the formula of what compound it will form. Then determine what kind of bond they will form. Is it going to be an ionic or a covalent bond? Then I want you to actually draw the Lewis structures coming together and forming the bond. And I want you to be explaining what's happening. So while you are explaining this picture or this stuff that you have drawn here in part 1, I want you to answer these questions. What kind of bond was formed? How can you tell? What is happening to the electrons during this type of bond? And what are the charges of each atom? Then for part 2, this is all in the same video, I'm going to give you nitrogen and fluorine. I want you to draw the Lewis structures for both ones. And then I want you to determine the number of bonds that each one wants to make. And then I want you to use the number of bonds to write the formula. Okay, like is it going to be H2O or NF4 or whatever, right? I want you to write out the formula. You'll have to cross and drop for that. And then I'll want you to determine what kind of bond they formed, covalent or ionic, and draw the Lewis structure and actually draw them coming together and forming that bond. Then you can answer these questions and explain what kind of bond was formed, how can you tell, what is happening to the electrons during this kind of bond. Now, important here, if you can't get Flipgrid to work, You can just take a picture of both of your things, and you can then put it on a Google Doc and answer and type out all the questions, and then you can submit that to Google Classroom instead. That's only if you can't get Flipgrid to work. Okay, so this is the link to the Flipgrid assignment where you'll be posting everything. I made an example Flipgrid for you to look at, so you can check out that link as well. Hey guys, the purpose of this video is to give you an example for your Flipgrid project this week. I'm going to be using a different set of atoms than what you've been assigned, so no cheating. So for part 1, I assigned myself sodium and oxygen. I drew the Lewis structures right here. Sodium has 1 valence electron, oxygen has 6. Now, I know that they're going to form an ionic bond between them. And the reason why I know that is because oxygen is a nonmetal and sodium is a metal, so they can form ionic bonds. Now, the charges, sodium is going to have a +1 charge, oxygen is going to have a -2 charge. And so when we cross and drop those charges, the formula for the compound that will be formed here is Na2O. There's going to be 2 sodiums. So here, I've got 1 oxygen, 2 sodiums, and since this is an ionic bond, sodium is actually going to give its electrons to oxygen. And so when oxygen takes those electrons, it's going to get a -2 charge, and the sodiums will each get a +1 charge. And so that'll make them stick together. And so they'll form a compound, Na2O. Now, the next set of atoms that I gave myself were sulfur and chlorine. Sulfur has 6 valence electrons, chlorine has 7, and so sulfur will want to make 2 bonds, chlorine wants to make 1. When we cross and drop those bonds, we get SCl2. So that means there's going to be 1 sulfur and 2 chlorines. Chlorine wants 1 more bond. Sulfur wants to make 2 bonds. And so here, they're going to form a covalent bond down here. Sorry, you might need to see that. They're going to form a covalent bond down here because chlorine and sulfur are both non-metals. So that means that they will form covalent bonds. And so here, chlorine and sulfur are sharing these 2 electrons, and then sulfur is also sharing another pair of electrons with this chlorine. Remember, please finish the school year strong. You have 2 weeks to do this assignment. I hope you guys will make the most of it.